Uh, Good morning, friends. Myself Shankar Bhanuse. In today's lecture, we are going to see uh, the next point of a complex variable, that is analytic function. Okay, let f of z is equal to u plus iv is said to be analytic function if it satisfies its ZCR equations. Ux is equal to vy and uy is equal to minus vx. And one more condition is there: all partial derivatives ux, uy, vx, vy are continuous. They should be continuous. Note that z is equal to cos theta plus I sin theta, and by De Morgan's theorem we will get 1 upon z as cos theta minus I sin theta. If you add these two, we will get 2 times cos theta, and if you subtract these two, z minus 1 by z, we will get 2I sin theta. These are the points which are important for MCQ type questions. Relation between the hyperbolic and circular functions which are necessary to convert the given, to find the real and imaginary part for the complex function. Sin ix is equal to, we can write sin hx, I sin hx. Sin ix we can convert in the form of I sin hx. Similarly, sin hix is equal to I sin x. If ix is there, hx will come with I is outside of that function, I is multiple to the function. Sin hx, sin hix there, therefore I sin x, h will get cancelled, x comes. Okay, circular. Similar way, if we move this I on LHS, we will get sin x is equal to minus I sin hix, or sin hx is equal to I sin minus I sin ix. Okay. Same now a relation for cos x. Cos ix is equal to cos hx. Here I will not come, and cos hix is equal to cos x. Remember, for cos there will not be I. Similar like sin ix, we can proceed for tan ix and tan hix, that is I tan hx and I tan x. One more thing, if you f of z is equal to log z, then it's we can express the function in terms of real part and imaginary part as half of log x square plus y square plus I tan inverse of y by x. It is a value of log z, half log of x square plus y square plus I tan inverse of y by x. Okay. Now let's start our examples. Consider the first example. Show that the following functions are analytic and find the derivative of that function, that is f dash of z. Okay. F of z is equal to e raised to z, the first function. As f of z is equal to e raised to z, we can put z is equal to x plus iy. To show that the function analytic, we want ux, the real and imaginary part, u and v, then only we can show that whether the function is analytic or not. For that, put z is equal to x plus iy, so that it becomes e raised to x into e raised to iy, so that e raised to iy is equal to sin x cos y plus I sin y. Separate the terms, we will get e raised to x cos y plus I sin y e raised to x. That is, u is equal to, comparing with the function f of z u plus iv, we will get u is equal to e raised to x cos y, v is equal to e raised to x sin y. Now find out the derivatives. Ux is equal to cos y as it is, partial derivative of u with respect to x, treating y as a constant, means cos y as it is, derivative of e raised to x, e raised to x. Similarly, uy, e raised to x as it is, derivative of cos y will be minus sin y, and vx is equal to e raised to x sin y as it is, and vy is equal to e raised to x as it is, sin y derivative cos y. If you observe that ux is equal to, we will get a vy, and uy is nothing but the difference between u and vx is the minus sign is there, therefore uy is equal to minus vx. CR equations are satisfied and all the partial derivatives are continuous, therefore f of z is equal to e raised to z, the function is analytic. As the function is analytic, that means it is a differentiable, therefore its derivative f dash of z is equal to derivative of f e raised to z is nothing but e raised to z. In this way you can solve the examples. Let's consider one more example. Let f of z is equal to log z. We know that in note we have seen the value of log z is nothing but half of log x square plus y square plus I tan inverse of y by x. Comparing with f of z, that is u plus iv, we will get u is equal to half log x square plus y square, v is equal to tan inverse of y by x. Calculate ux, that is half as it is log f of x derivative 1 upon f of x into f dash, therefore 1 upon x square plus y square into derivative of x square plus y square, it is 2x plus 0. Derivative of y will be 0 because we are differentiating u partially with respect to x, treating y as a constant. Similarly, we will get uy. Similarly, find out vx. Vx, derivative of tan inverse f of x is 1 upon f of x square plus dou by dou x of y by x. As y is a constant and 1 upon x is there, therefore derivative of 1 upon x will be minus 1 upon x square. If we simplify, x square get cancelled, we will get the derivative as minus y upon x square plus y square. Okay. Similarly, we will get the value of vy. Now if you compare, uy is nothing but vx, uy is nothing but ux is nothing but vy, both are same, and uy, that is double star and one more double star, the difference is of negative sign, therefore uy is equal to minus vx. CR equations are satisfied and all the derivatives are continuous. Therefore f of z is equal to log z is an analytic function. As it is analytic, it is differentiable. Therefore f dash of z is equal to 1 upon z. Let's go for one trigonometric example, that is for trigonometric functions, let f of z is equal to sine hyperbolic z, hyperbolic function, sine h of x plus iy, because z is equal to x plus iy. Now we know the formula sine hyperbolic a plus b, that is sine hyperbolic x plus y is equal to sine hx plus cos hy plus cos hx sine hy. Now in the place of iy is there, in the place of y, iy is there, put iy in the place of y, therefore sine hx cos y plus I cos hx sine y. How we have seen the relation, cos h is nothing but cos y without I, sin h is nothing but sine only with I. Therefore u is equal to sin hx cos y and v is equal to cos hx sin y. Find ux uy, derivative of sin cos hx cos y as it is, uy is nothing but sin hx as it is, derivative of cos y will be minus sin. Similarly, get the derivatives of v with respect to x and with respect to y, and if we compare, we will get ux is equal to vy and uy is equal to minus vx. CR equations are satisfied, all the partial derivatives are continuous, therefore f of z is equal to sin hz, that is sine hyperbolic z, is an analytic function, and if it is analytic, is differentiable, therefore its derivative as f dash of z is equal to cos hyperbolic z. Okay, let's consider one more example. This is the cos z. Let f of z is equal to cos z, f of z is equal to, put again x plus iy, we know the formula of cos a plus b, cos a cos b minus sin a sin b. In the place of y, again replace iy, cos iy, what is the value of cos iy? It is cos hy minus I sin x, sin iy is nothing but I sin hy, therefore u is equal to cos x cos hyperbolic y, v is equal to minus sin x sin hyperbolic y. Ux is equal to differentiation cos hy as it is, derivative of cos minus sin, uy cos as it is, cos hyperbolic derivative will be sin hyperbolic y. Similarly, get the derivatives of vx and vy. Ux is equal to vy by observation and uy is equal to minus vx, difference is of negative sign. CR equations are satisfied, all partial derivatives are continuous, therefore cos z is analytic and its derivative will be minus sin z. Note the formula is sin of x plus or minus y is nothing but sin x cos y plus or minus cos x sin y. Sin hyperbolic x plus iy, same formula, no change, but for cos x plus iy, if you consider, for plus middle sign will be minus, previous example, and if it is minus, middle sign will be plus. But for cos hyperbolic, for plus it is plus, for minus it is minus. Cos hyperbolic x plus iy, no change of sign, plus plus minus minus. But cos of x plus y, x plus or minus y, for plus minus sign and for minus it is plus sign. Okay, hope you have understood. No change for the cos hyperbolic x plus or minus y, it is change for cos of x plus or minus y in the formula. Okay, hope you understood. Thank you. This is the test, you can solve these examples, that is show that the following examples are analytic for the practice purpose. Okay, thank you.